Welcome everyone. Thank you for being here in my presentation. My name is Seddik, and I'm an AI researcher. And today I'll be talking about my experience leveraging GraphQL to work with my AI models. I work with a lot of data, so GraphQL was very handy for me fetching the data from the servers in order to use it to my models. I will be going through this agenda today, talking about traditional APIs and versus GraphQL, the importance of data in AI development, the challenges of for AI developers with REST APIs, GraphQL to the rescue, where GraphQL was solving a lot of challenges that we encountered when we were using the REST APIs. Then we'll be talking about GraphQL in AI development, giving an example of the autonomous car example developments. Then we'll be having like a summary of takeaways and conclusion after that. Cool. So generally speaking, in REST APIs, the server determines the shape of and the structure of the data, where client may receive more data than they needed or less data than they needed, as an example of an underfetching and overfetching. On the other hand, GraphQL empower client to define their data requirement through queries. So client can request only the data that they need, avoiding the underfetching and the overfetching issues that they were encountering with the RESTful APIs. That's not only the benefit of GraphQL when it comes to comparison with the REST APIs. We have seen different benefits. I will discuss them in the next slides. So what is the importance of data in the AI developments? So it's a hot topic of nowadays. Everything is running on AI today. And there is no AI, I would say, without data. Data is the backbone of the AI. If you don't have data, you don't have an AI. Or if you have like corrupted data or high or low quality data, you have not trusted AI. When we talk about data in AI, we focus on two things: the data quality and the data diversity. When it comes to data quality, we have seen issues with REST APIs, with incomplete informations, outdated information, and lack of standardizations. For example, when we're dealing with, when we're training an AI model for a car, an autonomous car, for example, an incomplete information comes when we fetch data about the location of the car, and we only receive the longitude instead of the longitude and the latitude as well. Outdated information. Most of the times, the autonomous cars move around the city, changing the location every single seconds, but we receive an outdated information where the location was for 5 seconds ago, 5 hours ago sometimes, and that will affect the AI model in the negative way. The lack of standardizations. For example, if you have, let's say you are trying to fetch the speed of the car, and sometimes some of the models, they give you like a speed in kilometers, and some of them, they give you the speed in miles per hour, and that will make a big difference in terms of trying to train your model to learn exactly where to be speeding, where to slow down. Data diversity in terms of AI importance. Most of the AIs nowadays suffer from bias. In terms of autonomous cars, we have seen bias in urban settings where we gave a small amount of data to our models, and the data was mostly for cars in the city, where we took the car to a rural area or suburbans. It did have some malfunctionings due to the lack of data. Limited weather generalizations. We gave also a small amount of data, or generally data about a mild weather climate. And when we took it to when we took it to a location when there was heavy snow or fog, the car wasn't performing well, and it made some accidents, and it caused some safety concerns. So that takes me to the next slide, where talking about the challenges for AI development with REST APIs. So the most challenges that we've seen are listed here. Most of them are overfetching, underfetching, rigid endpoints, overhead of multiple endpoints, and documentation and versioning. So for overfetching, when we use a REST API, we get data from the car, but we always get the whole data. The car, the sensors and the other components, let's say the weather data, the location data, the car IDs, and so on. And most of the time, we have to deal with cleaning those data. That made developers spending more time than needed cleaning the data that they don't need. Underfetching. In order to solve the overfetching issue, we created another API endpoint, and in that case, only querying the data that we need. But down the road, we found another problem where we query the data that we needed for the sensors, for example. We needed another data for the location, and in that case, we have to create another API call or another endpoint, leading us to the overhead of multiple endpoints. And we ended up with over 100 endpoints, and that made it very hard for us to document because REST API suffer from the documentation. And the more that we have, the more documentation issues will arise. Maintaining the documentation will be also a hard problem. We had to hire an extra person just working on trying to document the API and maintaining them, but that raised another problem where other engineers having like misunderstanding when it comes to the documentation for the APIs. Rigid endpoints are another issue where we did have only one API endpoint, and when we call it, it always gives us the same data, and that caused most of the time overfetching and the other time underfetching. So we were thinking what we can do. Most of the developers started creating or writing scripts in order to manage the REST API and the underfetching and the overfetching issues, but eventually we landed on the GraphQL. So we gave it a try, and this is the results. There was no underfetching or overfetching in the GraphQL. There is no rigid endpoint, as GraphQL are fixed endpoints that are dictated to the structure of the response. Versioning as well, GraphQL doesn't require versioning as a schema changes. And single endpoint. The good thing about everything, because our model use different data, we have to use different data many times in order to train our model. And the single endpoint was a blessing in that situation where we needed to just change the query and we ought to go. We don't have to create or reinvent the wheel or creating multiple endpoints. Documentation was also good. We saved a lot of time when it comes to this one here, and we cut a lot of meetings when we don't have to meet with other developers on the team in order to discuss the documentation and the standardization of that. Multiple requests, and that was helpful because as an AI developers, we rely on data from different sources. So multiple requests help us querying data from multiple sources using one API call. All right, now I'm going to give an example about GraphQL in development, and the example here is about the autonomous car developers. So we have an autonomous car, for example here. It has sensors and other components. It does capture data about the weather condition, the location, and the battery, and the speed, and so on. And we have multiple of them, hundreds of them. They query data, they capture data in real time, and they send it to the cloud server. Then as developer, we access those data in order to train our model. Basically here, this is an example, as I said here. The data are sent from the cars to the cloud service through a V2X, which is a vehicle to everything protocol. Then we used to use a REST API in order to fetch this data from the cloud and train our model with it. And here, as I mentioned before, we had a lot of issues, and we had to spend over 30% of the time just trying to figure out how to solve the problem of the underfetching, the overfetching, and one of the biggest problems was the real-time data. We were having, most of the data that we were querying from the API was kind of outdated, and it was affecting the accuracy of our models. But GraphQL, on the other hand, we were being able to leverage GraphQL with its declarative nature of queries, where whenever we need any data, we just query or we just ask for that data. For example, here, if we need location, it has subfields, the latitude and the longitude. we need location and battery. We get location and battery. We don't have to get any other data, and we don't have to spend more time on data wrangling. If we need more data, we just ask for that without even creating or developing or even designing other APIs. And as you see, the more you need, the more you get, or you can even cut some field or whatever you want. It's custom, so you get what you ask for. Schema stitching, that was also a big, it has a big impact on our AI model accuracy, where we did have multiple sources and data coming from multiple sources. That means we have to train our car or our model on different kind of on different kind of data in order to avoid the bias challenge with the AI development. So we were able to use only one query in order to fetch data from all the sources that we did have. This cut the time consumed on developing other queries in order to fetch the data. We didn't have to deal with multiple endpoints and documentation and so on. The other biggest impact on our accuracy when it comes to the model, the machine learning model, is the real-time data streaming. Before we use GraphQL, the data are transported from the cars to the cloud system through a vehicle to everything protocol, which rely basically on real-time streaming. Then from the cloud, in order to fetch the data or feed our model the data from the cloud, we did have a problem with the REST APIs. And again, most of the time we were running behind with the latency and then outdated data. We didn't have like an accurate information about the model and how it's behaving. But thankful to GraphQL with the feature subscriptions, we were being able to fetch data or feed our model in a real-time streaming. And that helped our accuracy by 2.5%, which was a big jump from the REST APIs. Other than that, when it comes to developer productivity, we have seen an impact on the time and the cost of saving. The nature of GraphQL intuitive query systems help the developer to communicate with the server and to understand the data effectively, and that remove every ambiguous and misunderstanding between the developers. And since most of AI developers are not software engineers, or I would say they are not web developers, they don't have that mentality of knowing what's behind the server or what is going on under the hood. They just need the data and work with it. So GraphQL was very handy. So if you ask an AI developer that didn't have probably an experience with software engineering or web development before, to probably solve some problems with latency or how do they fetch their data, they will probably spend 5 days instead of probably 1 day maximum. We have reduced development time by avoiding unnecessary data and unnecessary round trips of data by solving the overfetching and the underfetching challenges, where before the AI developer used mostly 20% of the life cycle, the machine learning life cycle, to collect and clean the data. That means they have to deal with data that they didn't need. They have to clean that data. They have to inspect that data. Do they need it? Don't they need it? And we're talking about millions of rows of data that takes at least days or even sometimes weeks in order to deal with. Developers spend less time writing boilerplate code. Before, with the REST APIs, developer has to come with a script or with a technique in order to solve the problems of overfetching and underfetching, and go beyond and above and beyond in order to get only the data that they need, but they will never get only the data that they need. As you see here in this chart, this is an AI development life cycle. It has everything that the machine learning model goes through. One of it here is the data collection and preparation. It takes 20% of the life cycle. And the other one is the feature engineering, which are the most two phases that they take the most of the life cycle time. And feature engineering is related in a way to the data collection and preparations. So if you want to cut the time or optimize this machine learning model when it comes to the time complexity, we better focus on the data collection here. Cutting this 20% was a challenge. We tried to create scripts, change sometimes like the architecture and so on, but it didn't help since we were relying on an API that suffered from underfetching and overfetching and so on. If you focus only on this part here, which is the data collection and preparation, and for the sake of simplicity, let's say 50% of the time used in this data collection and preparation is for data collection, and 50% is used for data cleaning. Data collection usually done by API calls. And if you have a REST API, that 50% is actually 50%. You have to use the whole 50% since you are querying data. There is a latency there. You are making multiple calls, and you are dealing with data that you don't need. That means you add another time to clean the data and inspect the data and have the data ready for your model. When it comes to the other side of the chart, 50% of data cleaning. We have seen that, leveraging GraphQL in this situation where fetching the data from the cloud in order to feed it to our model, we reduce the data collection to 25%, which allows the other 25% to be used for AI development. If you are an AI developers, you don't have to worry about how the data is coming to you, or you don't have to worry about like overfetching, underfetching. You just use that time for the thing that you excels at. Data cleaning as well, we have seen, we did cut it by, I believe it was 30%, but for the sake of simplicity here, let's say by half. And also that gave us time to use for other phases in the machine learning, as we see here, for feature engineers and so on. So how does feature engineering is being affected by the data collection and preparations? So data collection and preparation, again, it does rely on how do you fetch your data. And if you are fetching your data the best way, that means you don't have a problem, or you don't have that much challenges working on the feature engineering. It will be easier for you to feature engineers like clean and well-structured data rather than have to clean the data and try to make the data well maintained. And even if you do so, you will still have some problems with the feature engineering. So technically speaking, if you leverage GraphQL for data fetching, you will be solving a problem in this phase, data collection and preparation, cutting at least 50%. It will go down to 10% here. And for feature engineering, which is affected directly with the data collection and the preparation, you will be cutting at least 25% of this, which is 5% going down to 15. Those times here that's being used before for data collection and preparations will be used for something else. Will be used for the model training and tuning, and that will put developers ahead, probably 25% ahead. All right, let's see here. So key takeaways for whatever we went through today. We talk about the comparative advantages, how GraphQL is different from REST APIs in the way of an AI development. So GraphQL help you fetch only the data that you need. That means as an AI developers, you don't have to worry about reinventing the wheels or dealing with some backend or some other software engineering tasks that you probably do not excel at. So you don't have to worry about this phase. GraphQL will take that from your hand. Efficient data retrieval. This not only help with the underfetching or overfetching or solving some problems with the REST APIs, it does also help with you focusing only on the thing that you excel at. And also helping with the accuracy of the models. If you feed your models a well-structured data, you definitely will have a higher accuracy. But if you have some data that you have to get involved and clean the data and spend time on the data, and there is lack of standardization when it comes to documentation, that means you and your team, you are not 100% on the same page. That will lead to that will affect the accuracy of the model in, I would say, in a negative way. And when we're talking about the autonomous cars, that raises safety concerns because you have cars running out there They deal with traffic, they deal with other cars, they deal with pedestrians, they deal with passengers on board. GraphQL will help, I would say, not only with the time or with the data retrieval, it helps also with the model training itself, which lead to a better accuracy and model performance in general. Data aggregations, we have seen how GraphQL was handy when we had to deal with multi-sources. As an AI development for the autonomous car, we often use data from multiple sources. And in that case, data aggregation feature from GraphQL was very handy. We just needed one query, and we get everything in a blink of eye instead of having to go through multiple calls and multiple endpoints. Real-time data streaming, as we went through before, in autonomous car development, real-time or accuracy when it comes to the time is a big thing for cars development. Without GraphQL, we were trying to find ways in order to get data from the cloud in a real-time manner. That means we needed to have other people get involved in our development in general and work with something in order to give us the data in the same time. Even with that, we were seeing a little bit of latency where our models weren't given the correct location for some cars. But with GraphQL, we just did leverage the subscriptions here, and everything was working smoothly. Developer productivity, as we saw, developers no need for creating or trying to find ways to clean the data more than needed or to filter the data. They get only what they need from the system, from the cloud, and that will cut the time by at least 15% from the whole machine learning lifecycle. And in conclusion, data quality, data diversity, and efficient access are foundational in AI development, and the GraphQL plays an essential role in addressing these concerns here, making it a very essential tool for AI practitioners and developers. It is still in the beginning of, I would say, experiment with AIs, but we have seen a good impact on it, and we are very excited to use it with more things. Working as an AI developers, working with an APIs and with GraphQL, we had some ideas and future products trying to integrate AI into GraphQL, specifically for selecting resources when fetching the data. We have seen that GraphQL is suffering sometimes from fetching the data from the, I would say, from the correct or the perfect resource. And we had like a white paper that we are going to release probably next month, trying to integrate AI into GraphQL in order to optimize the data fetching. We are open for any collaboration or questions or even partnership. And that will take me to my last slides here, and any other questions. All right. Thank you for listening.